go over Part C of 2022 Gauss contest, grade 8 Gauss contest. Let's begin with question 21. So the positive factor of 6 are 1, 2, 3, and 6. There are two perfect squares less than 100 that have exactly 5 positive factors. What is the sum of these two perfect squares? Okay, so because if the perfect squares are less than 100, that means it can be 1 to the power of 2, 2 to the power of 2, 3 to the power of 2, 4 to the power of 2, 5 to the power of 2, 6 to the power of 2, 7 to the power of 2, 8 to the power of 2, 9 squared, and not 10 squared because 10 squared equals to 100. So the next thing we're going to do is to calculate how many factors each of them have. So first we can eliminate 1, 2, 3, 5, 7 because they're all prime numbers, therefore they only have 3 factors at most. And the next thing is to evaluate the rest of them. So the formula to evaluate the number of factors of a number is to use the exponent of of each prime factor plus 1 timed together. So for 4 squared, we can factor this into 2 to the power of 4, and this because 4 plus 1 equals to 5, so it's met the requirement. And for 6 squared, we can factor it into 2 squared times 3 squared, and the number of factor is 3 times 3, which equals to 9. And for 8, we can factor it into 2 cubed squared, which would give us 2 to the power of 6, and the number of factor would be 7. Therefore, it doesn't match the requirement. And for 9, we can factor it into 3 squared, which equals to 3 to the power of 4, and 4 plus 1 equals to 5. Therefore, 9 squared is the other perfect square. And if we add them together, we will get 4 squared plus 9 squared equals to 16 plus 81 equals to 97. Therefore, the answer is E. Number 22. In the list P, Q, R, S, T, U, V, each letter represents a positive integer. The sum of the value of each group of 3 consecutive letters in the list is 35. If Q plus U equals 15, then P plus Q plus R plus S plus T plus U plus V is what? Alright, so since each group of 3 consecutive number is 35, the sum of them, so we can write the equation P plus Q plus R equals 35, and Q plus R plus S equals to 35. And from these two equations, we can get that P equals to S. And then the next set is Q plus R plus S and R plus S plus T, and both of them equals 35. Therefore, Q equals to T. And then we have R plus S plus T and S plus T plus U. And R equals to U. And the next one is S plus T plus U equals 35, and T plus U plus V equals 35. And that means S equals V. Since we already know that Q plus U is 15, therefore we need to replace all the letters with Q and U as many as possible. So we know that we can replace T with Q. So we replace T with Q, And we can also replace R with U. And S equals to V. And S also equals to P. Therefore, we can use P to represent S, V, and P. So we replace S with P and V with P. Therefore, we can rewrite the equation into P plus Q plus U plus P plus Q plus U plus P. And we have two sets of 15 and 3p equals 30 plus 3p. And because we know that P plus Q plus R equals to 35, and we know that we can use U to replace R. Therefore, P plus 15 equals to 35 and P equals to 20. Therefore, the answer would be 30 plus 3 times 20, which gives us 90. So D is the correct answer. Question 23. The net shown is folded to form a cube. An ant walks from face to face on the cube, visiting each face exactly once. For example, A, B, C, F, E, D, and A, B, C, E, F, D are two possible orders of faces that the ants visit. If the ants start at A, how many possible orders are there? Alright, so if I want to visualize the cube, it should look something like this. If the top face is A, then this side would be B, and this is C. The bottom is F, and this side is E, and this one would be D. Right. So if the ant starts at A, then there are three possible cases. Case 1, the ants go from A to B, C, D, or E, and then it goes to F. Case 2, starts at A, goes to B, C, D, E, and then it still go to one of the adjacent side, and then it's go to F. And case 3, it starts at A, go to B, C, D, E, and then go to another side of B, C, D, E, and go to another B, C, D, E. Okay, so for the first case, the ant first have 4 options, and then after it's on one of the B, C, D, E, then it can only go to F. And after that, from F, it have 2 options because if the ants go from A to B and then go to F, it cannot choose E, because if it choose E, then one of C or D can never be visited. Therefore, there are only 2 options, not 3. And then for the rest of the step, it just times 1 times 1, which gives us 8. And for case 2, it would have 4 options for the first step, and then 2 options, and then 1 times 2 times 1, which gives us 16. And for the third case, it's the same. So we would have 4 times 2 times 1 times 2 times 1, which is 16 as well. Therefore, if we add them together, we will get 32 plus 8 equals to 40. Therefore, the correct answer is E. Number 24. The number 385 is an example of a 3-digit number for which one of the digits is the sum of the order 2 digits of the other 2 digits. How many numbers between 100 and 999 have this property? Alright, so to do this type of questions, we can list out all the options we have. So let's start with 1. So for 1, we can have 1 equals to 1 plus 1. And because we can't start a number with zeros, therefore there are only two options. And then it's 2 equals to 2 plus 0, which have two options. And then we have 1 plus 1, which will give us three choices. And then 3 equals to 0 plus 3, which would have two options. And then we would have 1 plus 2, which have 3 times 2 times 1, 6 options. And after that we have 4, which equals 1 plus 0 plus 4, and then 1 plus 3, then 2 plus 2. And then we will have 3 options for 2 plus 2, 6 options for 1 plus 3, and only 2 options for 0 plus 4. And 5 equals to 0 plus 5 equals to 1 plus 4 equals to 2 plus 3. And it would have 2 options for 0 plus 5, 6 options for 1 plus 6, 6 options to 2 plus 3. And 6 equals to 0 plus 6 equals to 1 plus 5 equals to 2 plus 6 equals to 3 plus 3. And we will have 3 options for 3 plus 3, 6 options for 2 plus 4, and 2 options for 0 plus 6, and 3 options for 1 plus 5. And for 7, we also have 0 plus 7 equals to 1 plus 6 equals to 2 plus 5 equals 3 plus 4. And this would give us 2 options, 6 options, 6 options, 6 options. And for 8, it has 0 plus 8, 2 options, 1 plus 7, 3 options, 2 plus 6, 3 options, 4 plus 4, 3 options. For 1 plus 6 and 2 plus, for 1 plus 7 and 2 plus 6, there are 6 options because 3 times 2 times 1. And for 9, so last number, we will have 0 plus 9, 2 options, 1 plus 8, 3 options, 2 plus 7, 6 options, 6 options, and 3 plus 6. We also have 6 options, and then it's 4 plus 5, which also have 6 options. And if we add them all together, we would get 2 plus 5 plus 8 plus 10 plus 14 plus plus 16. Oh, sorry, so for this one, 1 plus 5, there is also 6 options. Therefore, for 6, there are 16 options. And after that, we would have, so for 6, so for 6 we have 17 options, because for 3 plus 3 we also have 3 options. And for 7 we have 20 options. And for 8 we have 2 plus 6 plus 6 plus 3, which would give us 11. And then for 9 there are 26 options. And if we add them all together, we would get 126. Therefore the answer is B. Okay, and then is the last question. Student A, B, and C have been hired to help scientists to develop a new flavor of juice. There are 420 samples to test. Each sample either contains blueberry or does not. Each student is asked to taste each sample and report whether or not they think it contains blueberries. Student A report correctly on exactly 90% of the sample containing blueberries, and report correctly on exactly 88% of the sample that do not contain blueberries. The results for all 3 students are shown below in the chart. And student B reports 315 more samples as containing blueberries than student A. For some positive integer m, the total number of samples that the 3 students report as containing blueberry is equal to a multiple of 5 between 8,000 and 9,000. the sum of all value of m is what? Alright, so if we set x to the number of a blueberry sample, and for 1,200 minus x is the number of no blueberry sample. Then the number of samples that student A reports as containing blueberry would be 9/10 plus 100 minus 88/100 times 4,000 minus x, and this would equals the number of samples that student B reports that actually have blueberry, which would be 88/100 times this would be 98, not 88. It would be 98/100x plus 100 minus 86/100, 4,200 minus x, and because it says student B report 315 less than student A, therefore we need to minus 315. And if we expand this equation, we would get 98 minus 14 plus 12 minus 90/100x equals to 231, and x would equal to 3850. And if we plug this back into this equation, the initial equation, then we would get that the total number correctly reported sample that actually contain blueberry would be 9/10 the number of sample plus 12/11, which we got from 100 minus 88/100 times 350. And we got 350 from 4200 minus 3850. This is from student A, and from student B we would have 89/100 times 3850 plus 14/100, 350. And for student C it would be 2m/100, 3850 plus 100 minus 4m/100, 350. And then we would get the total number the samples that actually contain blueberry to be 7679 plus 63m. So because the question already told us that the number resulted from the equation should be between 8,000 and 9,000, therefore we'll get that 8,000 is smaller or equal to 7679 plus 63m, which is also smaller than 9,000, and therefore m would be greater than 6 and smaller than 20 inclusive. And after that, the next thing we're going to do is just to try different value of m. That's what makes this equation have a result of multiple as a multiple of 5. And because we know that all multiples of 5 end with 0 or 5, therefore 3m must end with either 1 or 6, and m can be 7 or 17 for the case that 63m end with 1, and m can be 12 with the case that end with 6. And if we add them together, we will get 7 plus 17 plus 12, which gives us 29 plus 7 equals to 36, therefore B.